Welcome to Learning with Lai. In this video, we're going to be talking about converting from improper fraction to mixed fraction or vice versa. So let's take, for instance, we have this improper fraction 23 over 4. To take a crack at this, we would need to revisit our long division because if we can recall, 23 over 4 also means or is equals to 23 divided by 4, and we're going to revisit our long division. And for us to do that, we're going to form a kind of step. I'll put the numerator inside the step. We're going to put the numerator inside the step and our denominator at the beginning of the step. So now the next thing we're now going to do is that we're going to look at how many 4s can we take from 23. If, for instance, we have 23 pieces of matchstick, how many 23 can we take? But I'm going to only do this illustration for this first example. So let's take, for instance, we have 23 matchstick. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So now we're going to now look at in how many 4s can we take out of this matchstick. So we have 1, 2, 3, 4. So I'll circle it. 1, 2, 3, 4. So that's 1. 1, 2, 3, 4. That's 2. 1, 2, 3, 4. That's 3. 1, 2, 3, 4. That's 4. 1, 2, 3, 4. So that's 5. So that means we can take out 4 matchstick from 23 matchsticks, and we're going to be having 3 matchsticks left. So that means we're going to have 5 on top here. That'll be, we're going to have it 5, and 4 times 5, because if you look at this, 4 in 5 places, that's 20, and when we subtract to know the remaining matchstick left, we have 3, based on this same illustration. So now the numbers of 4s or the number written on the step is what we're going to have as our whole number, because if you remember, mixed fraction consists of a whole number and a proper fraction. So this will now be 5 whole number. How many our remainder left using the illustration of the matchstick? So that will be 3 out of 4. So we're going to still have our 4 here. Our denominator doesn't change, so it's still going to be the same thing. And if we now want to try and go back to see if we're going to have the same improper fraction, what we're going to do is like we're going to do a kind of curve starting from the denominator all to this point here. So, and this will be, we have a multiplication sign here and we have a plus sign. So, or we can do it the other way around. We're still going to get the same thing. So 4 times 5, that's 20, or 5 times 4, that's 20, plus 3. So we'll have 23 over 4. So we can see it now. We've already done it, going from improper to mixed fraction, and from mixed going back. So if you want to go back, you put the multiplication sign between the whole number and the denominator, and you put the addition sign between the whole number and the numerator. So you multiply it, the answer you get, you add it to your numerator. So that's how you get your improper fraction back. Let's look at another example whereby we have another improper fraction. Let's take, for instance, we have 17 over 6. Revisiting our long division, we're going to draw a step. We put in our numerator in the step, our denominator at the beginning of the step. So we now ask ourselves, how many 6 can we take or can we get from 17? If we look at it, that's going to be 2. If we do the idea of the matchstick, you're going to see that you're going to have only 2 6 taken out from 17, and when we want to find our remainder, we multiply this will be 6 times 2, 12. We subtract, so our remainder left will be 5. So now we have our whole number here, the number on top, that's 2 whole number, and remainder 5/6. And if you want to change it back to improper fraction, we try and make our curve back again, coming back here, and we'll put a multiplication sign, I'll put a positive sign. So this will be 6 times 2, 12. 12 plus 5, that will be 17/6. So we can see that we're going to still get the same thing. It's very simple. Let us look at another example again on improper fraction. Let us take, for instance, we have 123/12, and if you can see it, the denominator is smaller than the numerator, as I've earlier explained in the types of fraction video. So in solving this again, we go back to our long division, we draw a step, and we have 123. We put our denominator at the entrance of the step, at the beginning of the step. So we now ask, how many 12 can we take out of 123? And that is going to be 10. If we try and use the stick method, it's going to take time, but we'll try and look at it, which multiple of 12 is closest to 123, but not more than 123. So 12 times 10, that will be 120, and when we subtract this, our remainder left will be 3. So we have our whole number to be 10. We have our whole number to be 10 whole number. Our remainder left 3/12. And if you want to check this, we can go back and look at it. So this will be multiplication and addition sign. So 10 times 12, 120, plus 3, so that will be 123/12. We can also look at 123 because we can reduce our answer here to a simpler form if it is possible, and that's another topic which I'm going to explain, but I can give a brief hint about it here. So this will be 10 whole number. So since we have our proper fraction, because a mixed fraction consists of a whole number and a proper fraction, we can divide where it is possible by the same number, only affecting our proper fraction. And when we divide 3 divided by 3, that will give us, so we still have our whole number, and this will be 1/4. So let us look at this here now, 123/12. If we try and see if we can reduce it to a lower form, which it is possible, we can divide by 3, both sides by 3, and when we divide 123 divided by 3, we'll have 41/4. And if we try and look at solving this with the long division method, we have this 41, we have 4. How many 4s can we take out of 41? That will be 10. A multiple of 4 that is less than 40 but not more than 40, that will be 10 times 4, that will be 40. And when we subtract this will be 1, and we can see that we have our whole number, 10 whole number, 1/4. So it's still the same number, but all what we're having here is just what we call equivalent fraction, and we're going to look at that in another video.